This demo illustrates the idea of a class in Java. Unlike other computer languages like C++, everything in Java must be a class. In other words, every file must be a class. Typically, you would start a class file with public class and then the name of the object that you're defining, such as bank account, or person, or student. In this case, because this is a demo program, I'm going to name the class BankTest, and I'm simply going to put a system out print statement inside of our public static void main string args method. To start us off. This is your classic hello world program, Java style. And when executed, this program simply prints out hello world. The name of the class is BankTest. If I saved this on my hard drive as a file and used it in an IDE such as NetBeans or Eclipse, the name of the file would be banktest.java. In this case, I'm using the website compileonline.com to test this program, so it's not really a standalone file, but it mimics it. Well, because the purpose of this example is to show you how a class, a reusable class, would be defined and implemented, I'm going to tack onto this, tack below this test class, I'm going to create the actual class here named bank account. Classes should always begin with a capital first letter, the name of a class in Java and many other computer languages such as C++. As of now, when I execute this program, we still just see hello world, but the purpose now of this driver file, the part above my row of asterisks, is the driver, the test driver. So I'll annotate that with comments. I'm just going to call that a test class. The whole purpose of the top portion here is to test the class that's being defined below. Well, at this point it still prints out hello world, but let's go for it and let's try to create a bank account object in this main method in order to use it for some productive reason in BankTest. Let's say the bank account belongs to me, and let's say it's my savings account, so I'll just call the object savings account. So this is your typical line of code that declares and instantiates an object. You might have already studied how to declare a primitive local variable such as num and how to set it equal to, say, 0. You later could change that variable to assign it the value 10, and you've probably learned how to system out print that variable. So if I ran this program, we should see a 10 printout, and we will once I comment out that line of code. The value 10 will be printed out. Oh, by the way, anytime that you put two classes in the same file, you can't have them both be public. So I have to take away the word public. Normally that would appear if this were in its own file. So now when I run the program, we will see the number 10 print out, simply because we're creating a local variable named num, we're assigning it the value 10, and we're printing it out. So in the spirit of declaring a variable, I could declare my bank account object and name it savings account instead of num. It would be ridiculous to set it equal to 0, because an object needs to be instantiated and not simply initialized to into a number. So the way to do that in Java is to type the operator new and to type the name of the class, usually with empty parentheses followed by it. The name of the class bank account is defined right here. That's on our to-do list. And the use of the empty parentheses, well, we'll study that later. So I run the program again. And let's see if it compiles and executes. Well, we're lucky. It seems to have run with no errors. But it doesn't do anything, so we actually have to create what's called a constructor. Constructors in Java must be named the same as the name of the class that they are in. So the constructor is typed out like this: public bank account, empty parentheses with empty curly braces in this case because, well, we don't know what a bank account is. So this is your definition. This is your declaration, really, of a bank account object. The program runs right now, but it's very uninteresting. What does a bank account need to have? Abstractly, what does a bank account hold as its data members? Well, we need to define those data members before anything practical goes on. Certainly there needs to be an amount of money in a bank account. So let's create a property, or a data member I should call it, and let's give it a data type, like some amount of dollars and cents, and let's name it like the balance, because the balance at any given time is what a bank account needs to know. So the program still executes, but nothing prints out here because we don't have any system out print statements anywhere. Well, what this right-hand side of the equal symbol is doing is it's giving birth to a bank account object. So we need to set it equal to 0, set its balance equal to 0. In this constructor that is being called or executed when this part of the code executes, this is where, inside the curly braces of course, this is where we need to set balance equal to 0. So now we actually have a bank account that has $0 in it. Let's pretend that we're really nice at this bank and we give everybody a free $100 when they set up a bank account, sort of like a welcoming gift. I run the program and that $100 doesn't print out. Well, that's because we still have no system out print statements. But at least now, up in the test class, we do have a bank account object being created. Its name is savings account, and it does actually have $100 in it. So to print that out, we could type system out print ln or print f, whatever your output method happens to be, and we type savings account dot balance. Using the dot operator that you see in any object-oriented programming language, such as C++ or Java, often this works. Let's check it out. Let's run the program and see if 100 prints out. And it does, 100.0, because it's a double, it prints out the 0.0 here. But this is horrible style. By default, data members, I should annotate that right now. I should tell other programmers what this top portion holds. This section right here will be reserved for constructors. The data members should not be public, and by default, everything is public here. Well, actually protected, but you can consider that to be public as well. Everything's public, and that's no good. So we explicitly type the word private. That modifier private will now prevent this program from executing. Watch. There's an error. It just doesn't like it because balance is considered to be private and therefore off limits up here in this separate class. So when something is private, even though it does exist, that data member does exist and happens to have a 100 stored in it, we need what's called an accessor method. So another area of our class is reserved for accessor methods. And the way you type an accessor method is you type public, in this case double, and you would say get balance would be good style. The job of an accessor method is to return the data member that it was created for. So this accessor method is for the data member balance. So therefore we type the keyword return balance. The program still gives an error when we run the whole test class. Because now, instead of attempting to directly access balance, which is private and therefore inaccessible up here, we have to actually type get balance, the name of the accessor method. And we need these empty parentheses just to tell the compiler that this is indeed a method and not a data member. So now we run the program and it actually prints $100 again. A much more long-winded way of doing that, but now it's much better style and it will help us down the road for reusability and safety. Bottom line is the data members should always be private, and therefore each data member that you happen to have in this section of your class should have its own accessor method. The data type double must be typed here because that matches the data type for balance. And you just simply return the name of the data member, and that's the whole job of an accessor method. Okay, at this point we have a test class and a regular class. The regular class has one data member, one constructor, and one accessor method. It would be good to have what I call a other constructor below this constructor here, which I often call the default constructor. So let's make a note of that. This is the default constructor. And I'm just going to copy and paste to be lazy. And right below that, I'll put a copy of itself and modify it into a other constructor, or just a regular constructor, I guess you could say. This constructor is going to take a pass parameter, and that pass parameter needs to be a double, and you might name it new balance or something like that. Instead of automatically initializing balance to 100, we're going to initialize it to new balance, which is a number to be determined. To test this other constructor, I'm going to modify my test class up here, and instead of having empty parentheses here where you see bank account, I'm going to put the number 200 in there just for fun. So some rich person comes into the bank, and instead of taking the free $100 that I get, I'm going to tell the bank that, well, I'm going to deposit $200 when I open up this new savings account. That 200 gets passed as a parameter and plugs in for new balance, which of course from right to left assigns itself into the data member balance. Now that's no fair because the guy who deposits $200 should still get the $100 for free. So just for fun, I'm going to add that new balance to the original 100 just to make sure that 300 now pops up on the output screen when I run this program. And it does. It's now 300. Because in the test class, we are instantiating a bank account object with a special number 200. The software just knows to execute this constructor, the other constructor if you will, instead of the default constructor. Because there is an integer or a number, a double, inside the parentheses, it knows to match up with this header and to execute this method. In fact, this will accommodate dollars and cents, like $200.99. If I run this program, it will print out $300.99 because the data member balance is a double and not an int. Now, another way to do this is to use the keyword this in Java. Right here, instead of setting balance equal to 100, I'm going to comment that out for now. Now that I have this other constructor, I can type this 100. And you know what? Forget about that fairness where we're supplying $100 for free. This is the real world. The bank's not going to give you $100 for free. So let's just say that when you set up a new bank account, you get $0 in your bank account if you don't come into the bank with any initial money. So check out this syntax as I run the program to check to make sure it works. Yep, it's currently printing 0.0 as you see. Here's why. The line of code where my mouse is waving over declares and instantiates the bank account object with the empty parentheses there on the constructor. Therefore, this code executes. Empty parentheses right here. Well, this code executes because it's the body statement there. And the word this tells the computer to find a constructor. The word this kind of means bank account in this case. And find a constructor that takes some kind of number parameter. Well, the only other constructor here is this one right here that happens to take a double or an int. Of course, I could have typed 0.0 there, which of course is a decimal number. And that 0.0 gets passed to new balance, which then goes from right to left, and that 0.0 is still being plugged in to balance. Now heck, we could have just typed 0.0 right there and directly did all this without calling another constructor. But you'll find that this is, well, this is the style. We use the word this in a lot of situations to make software more easily upgradable. So I'm going to delete this sort of hard coding way of doing it, and I'm going to use the slick this operator. Okay, let's line up my comments here vertically. Nice. And run the program just to make sure it still prints out 0.0. And I guess I should tell people what that is. So your balance is, and I'll use the plus for string concatenation. In C++, I think it's I don't know if that works. It does in some situations. But anyway, the plus is being used there to glue two strings together. Or in this case, a string with some double, a value that's a double. And it does work, as you see here. Now it says your balance is 0.0, and I should throw a $sign in here because we're talking about US American dollars. Okay, so far so good. We have a class bank account with one data member. That's not realistic in the real world. A lot of times we have much more than one data member. So let's pretend that this account needs a name, like the name of the person who has the account. That name would surely be a string, capital S, by the way, and I'll just, well, name it name. I don't have time for first name and last name. We'll just put the person's whole name together in one property. I guess you should explain these properties as you go with a little comment statement here. So balance here would be how much money is in the account, and the name, of course, is, well, the name of the account holder. And just because it's the other way around in my demo program, I'm going to put these in the other order to match up what you see on the website. There we go. Well, usually all data members should be initialized to 0 or something interesting in your constructors. So let's jump down here to our other constructor and just hardwire the guy's name to empty quotes. For now, it's a person with no name. And what if somebody tries to put negative dollars into their bank account? Right now, that would be allowed to happen. Let's pump negative $99.99 here into this other constructor call and see what happens. Yeah, the guy's starting off life with negative $99.99. I don't want to allow that. At worst, the guy starts with $0 in his account. So let's throw a little if statement in here, some conditional logic that prevents, oops, wrong place, that prevents that from happening. So here in this other constructor, I'm simply going to say if new balance is greater than or equal to 0, then I'm setting balance equal to new balance. Else, by logical conclusion, he must have typed in a negative number. So I'm just going to then give him $0, even if he's trying to take negative $99. So in this case, because negative 99.99 plugs in for the parameter new balance, and because negative 99.99 is not greater than or equal to 0, the else executes, and balance still ends up at 0, even though the idiot tried to put negative 99 in there. Let's verify. Yep, his balance is 0. So we put some error handling in this constructor. Nothing needs to change here in the default constructor because it's automatically putting a 0, and 0 is not negative, so that's fine. For good style, I personally like to use curly braces even when you only have one line of code in the body of an if-else clause. It's just a kind of safe program. Should we assume that somebody's name is John Doe if they don't provide a name? No, probably not. So I'm just going to leave that name as an empty string for now. Okay, the program currently works. Or does it? Yep, and it's currently printing $0. Last of all, almost last of all, let's create a method that resets the account if at some point it gets messed up in the world. So I'm going to come down here, and I call this kind of thing a interesting method. Some people call it, no, before we even do that, let's add in a modifier method. Yeah, all of these are modifier methods, we'll just say. Modifier methods are methods that mess with the properties, the data members, in a way that, well, changes their values. First modifier, the method that I'm going to choose to add, is one that withdraws some money. It's got to be public. All methods, including your constructors, should always be public, whereas the data members should be private. So this method is going to be a void method named withdraw. I'll explain the void later. We do have to specify how much money we're withdrawing, so I'll just create a parameter called amount. And we need curly braces for the body of this method. And logically, we would just take balance and subtract from the balance the amount of the withdrawal. So it's just one line of code here. Balance equals balance minus amount. Okay, we have a nice little modifier method that modifies the current balance, that data member. Let's test to see if it works. Up here in our test class, let's take savings account and do a withdrawal. To call that method, you just type dot withdrawal and specify how much money you want to withdraw. And let's just withdraw, say, $30. For this to be meaningful, we do have to put some money into this guy's account. So I'm just going to, in this case, initialize or instantiate the account with $100. If I withdraw 30, we should see 70 print out. But to print something out, I have to copy and paste my system out print. So I'll see the balance before the withdrawal and the balance after the withdrawal. Let's test. Yep, it went from 100 to 70. Okay, so here we are. We have a class that has a couple data members, a couple constructors, an accessor method for balance, and a modifier method that, well, reduces balance by some amount. Oh, by the way, balance equals balance minus amount. That can be consolidated using the minus equals compound operator, if you like that terseness in code. One thing I forgot to point out, accessor methods, such as this simple one, often begin with the prefix lowercase get. Remember that constructors always must be named the same exact thing as the name of the class that they are in. Bank account, bank account, bank account with a capital B. And data members, as well as methods, should always begin with lowercase first letters. Okay, moving on. Another modifier method that would be convenient to have in this class would be one that resets the account for whatever reason that the banker would need to do that. So let's make it another public void method and name it reset account. And when we reset an account, let's allow the person to provide their name. Let's say it's a woman that got married, so she has a new name. And coming into marriage, she has a new amount of money that she wants to initialize her new account with. So I need two parameters here. One's going to be the name parameter, that's a string, and the other one's going to be some amount of money, and we'll just call that new balance. I need curly braces for the body of this modifier method. Modifier methods are named modifier methods because they change and modify the values stored in the data members. Notice the lowercase r in reset account. And now let's go for it. Name equals new name, semicolon, and balance equals new balance. Pretty simple. To invoke this method reset account and test it, we need to slide up into our test class to make sure it works. So let's scroll up here real quickly, and savings account reset. Reset account. With the new name, Mary Smith Doe, because she got married to a guy named Doe, so she took her maiden name Smith and did the little hyphen thing and added to Doe. And she's coming into marriage with $1,000, we'll say, into this account. Verifying that that works, I'm going to copy and paste my system out print statement and run the program, and let's see if she now has $1,000 or not. Yep, she now has $1,000. She effectively reset her account. So this method reset account does that. We still haven't given these people a name. We're not, well, she has a name, but she didn't before in the account status. We'll eventually get to a point where we're testing to see if the name prints out. Okay, we're almost finished. We need a, well, we have display balance. No, we don't have a method that displays balance. We have a method called getBalance. So let's create a method called displayBalance that makes our output look pretty. Public void displayBalance, capital B there in displayBalance, empty curly braces, and this is where we'll put a nice system out print statement. We'll use print F here. Get some practice using that. Your balance is currently $, and we'll tell the computer that this is a floating point value, something with decimal places. So copy that syntax down. We're using the printf method. And the way this works is the decimal number, in this case a double, that's stored in this variable after the comma, gets plugged into the spot with the %f. And by having 0.2 there, we're rounding it to the nearest penny. So the %2f is sort of the placeholder for balance. The \n, of course, gives us a new line so that things don't run together in the output window. Now, if I ran this program right now, it wouldn't print this because we're not calling display balance. So up here, everywhere that I was doing using get balance. Let's change this to display balance for a nicer output, arguably nicer. Display balance, because I now have a method called display balance, and it's kind of superior to the get balance method. Let's run the program. Oh, I have errors. Hold on a second. Oh, it's not void. Hey, it is void. Oh, whoops, my mistake. To use display balance, we no longer need the system out print statement up here because that's built into the display balance method. The system out is already there. So see you later, system out print ln, as well as my temporary phrase, your balance is. I'm going to shorten this code in my driver program to simply this series of sequence of call statements. In a way, this looks very elegant. Savings account display, savings account withdrawal, savings account display balance again, savings account reset account, and savings account display balance. Let's run the program, and there's still an error message. We need a semicolon somewhere, perhaps not. Okay, so we clean this program up. It's just a nice sequence of call statements, fixing this extra right parenthesis there and running the program. Okay, so there we are. We have cleaned up the missing parentheses there. I run the program and it prints out basically the same thing as it did before, but we're using a nicey display balance method. These three methods are void because they don't return any number or value like a string. This method up here, get balance, it had double here because the data type being returned, balance, had a data type that was defined as declared as a double. So in Java, it's a requirement in your method header to specify what data type is being returned. And don't forget, you should always make your methods public for good style. So there you go. It's a very simple, almost crude bank account class. And we should explain how it works to other people that happen to find this bank account class out there, or coworkers and all that. So at the top of each method, right below the header, but above the curly braces for the body, the implementation, you should declare pre and post conditions. So for example, the bank account default constructor. Well, I'm explaining. A default constructor, oh no, I'm sorry, what it does. A default bank account object So there you go. It's called the post condition. It's a promise to the people who use this constructor in client programs like this up here. It's a promise that of what it's doing. So this constructor is indeed creating an account with the name set to empty string and a balance set to $0. Now it does it in a roundabout way by calling the word this, which really calls the other constructor, which does the heavy lifting. Okay, and then my other constructor, the purpose of it is, okay, so I've added some pre and post conditions to some of these methods. I didn't get to all of them down here. But a precondition is a promise as to what the parameter is going to be like, whether it's a positive number, negative number, or some other characteristic. A post condition is a promise from the class developer explaining what the method will do after it's finished executing. Pre and post conditions are important so that everybody can work together on a team and understand each other's code. Okay, the program currently works, but I want to show you a potential error that you'll have down the road with constructors if you're not careful. If I have a program which has no default constructor, temporarily I'm going to cut that out. This program will execute and work the same as it did before, because currently in the client program up here, I am calling the constructor that takes a parameter. That 100 is being passed down to New Balance. But if I try to delete the 100 and run the program, it's going to crash, because there isn't a default constructor right now with empty parentheses. It's not there. It was there, but I deleted it. And the computer doesn't just plug in, it doesn't call this one and plug a 0 in just because it's a nice guy. No, it's an error message. So it's always safe for a class developer to supply a default constructor even if there's a other constructor. Similarly, if you didn't have this other constructor here, and, well, in this case it's going to run, everything's going to run fine, because, well, this no longer works because it was calling the other constructor. But if I typed in balance equals 0 here, it would work fine. But if you typed in 100 and the computer goes looking for a other constructor that takes one parameter, in this case it's not there, and it will bomb for a couple reasons. Because it didn't find that other constructor. Now here's the real weird thing. If you provide no constructor, I'm going to delete both constructors. You can still default construct an object. It works. It throws a 0 in there by default, but it works. If you provide a other constructor but no default constructor, as I think I explained a minute ago, this will fail, because the default constructor is not supplied for free if one or more other constructors are typed out. I think C++ still goes and it provides a default constructor in this case, but Java doesn't. So again, in general, in summary, it's always good to have one default constructor and one or more other constructors depending on your program. For example, I could have another other constructor that allows somebody to specify their name. With a simple change here, string, new name, and instead of null string there, empty quotes, I could type in John Doe. No, I'm sorry, new name. And now, if I choose up here, I can allow the person to type in their name along with some amount of money. Because there are two parameters here with a string followed by a number, the software will pass over this constructor, pass over this one, and will automatically match these two parameters up with this constructor here, and therefore provide the person with this new name and end up in the correct balance. Let's check. Now, it did execute. The $900 did get into the account, and the name behind the scenes really is Bill Smith.